Welcome. In this video, we will take a look at a problem coming from chapter 8.4. We're looking at some roots of complex numbers. In this example, we would like to go out and find the 3 cube roots of 4 square roots of 3 plus 4i. So the first thing we want to do here is to just consider how to write this standard complex number in trigonometric form. So we're going to take that complex number and look at what its trigonometric form is going to look like. So if I look at the complex plane with positive 4 square roots of 3, and 4i, this is going to be in the first quadrant, and it's going to have a vector with 4i in my imaginary axis, and we'll have 4 square roots of 3 in my real axis. That would be the x-axis here. And we'll have a vector going out in that quadrant. Draw that a little better. This is going to form a 30, 60, 90 triangle if we're aware of that. This will be of length 4, and then we'll have a length of 4 root 3 on our x-axis. This is going to give us ratios of a 30, 60, 90 triangle. If we were to work out the modulus for this vector, we would say taking our 4 square roots of 3 squared plus 4 squared, and then taking a square root, we could find the modulus of this vector, or the length of that radius r. We'd find this to be square root being 16 times 3 plus 16, or adding all that together will give us 64 with that, which makes this modulus equal to 8. So this in fact is the ratios of a 30, 60, 90 triangle, where we have a 30-degree angle as our argument. So we have a 30-degree angle as the argument, and the modulus r is equal to 8. So let's rewrite this in trigonometric form. This would be z is equal to 8, and we'll have cosine of 30 degrees plus I sine of 30 degrees. So this is the complex number that we're working with. Now we can take a look at this root theorem and consider what the cube roots will be. So with the cube root theorem, we're going to be looking for 3 of these cube roots. The first cube root is when k, the counter, is at 0. So we're going to set k equal to 0. In this case, since we are taking 3 cube roots, we would want n to be 3. So n is always going to be 3 in this problem. So let's remind ourselves of that. So n is always going to be 3. So let's start with the first case. So if k equals 0, then our first complex root we'll call w sub 0. It's going to be equal to r, which is our 8 cube rooted. If I do a 1/3 power, that's really a cube root, which is going to turn into just 2 for us, but we'll work it out for this first one. If k is equal to 0 in our first calculation here, that will force this 360 times k to be 0, and so we'll just do theta divided by n. So here we'll have cosine, theta is 30 degrees, And our n, again, is always 3. And then we'll do plus I sine of 30 divided by 3. So just a little bit of simplification for w sub 0. This will be 2 for 8 to the 1/3, and that'll happen 3 times. And we'll have cosine of 10 degrees plus I sine 10 degrees. And that will be my first cube root. So we are 1 down, 2 to go. The next case is where k is equal to 1. So we're going to do the same formula, but now k is going to be equal to 1. So let's rewrite that with w sub 1. We'll still have 8 cube rooted, or 8 to the 1/3. We'll now have cosine of 30 degrees plus 360. And since k is equal to 1, we'll just be adding 360 one time here. And then divide by n, which is still 3. So we'll divide by 3. And then repeat that. So we'll have plus I sine and the same ratio. So 30 degrees plus 360 over 3. Try to give me a little bit more space next time. So we'll simplify this one for w sub 1. We'll still have 2 as the modulus. We take a look at the argument angle that's inside. We would have 30 plus 360 is 390. And if we divide that by 3, that'll divide evenly. That would be 130 degrees. So we have 130 degrees. I sine of 130. So that's our second cube root. And now the last case is where k is equal to 2. So this will get us our third. So when k is equal to 2, I'll just do it over here in some blank space. K equal to 2. So we're doing w sub 2 now. This will be equal to, again, 8 raised to the 1/3 cosine of theta. For us, theta is still 30 degrees plus 360 times 2. That's our k. And divide by 3. And then we'll do plus I sine of that same ratio. We'll try to sneak it in. So that'll be 30 plus 360 times 2. So again, we'll try to simplify this w sub 2. That'll be 2. If we consider what angle we're going to have in the cosine function, cosine, we'll have 360 times 2 is 720, and then plus 30, that will be 750. And so 750, and we want to divide by 3, that'll be a grand total of 250. So 250 is going to be the new angle that we'll use as the argument. in both of these cases. And we'll end with a bracket here. Bracket these off. And that will be our last cube root. So that's a third cube root for this case. So we have our three cube roots, w sub 0, w sub 1, and w sub 2, using our root theorem, where we are taking the k sub 0, or k equals 0, k equals 1, and k equals 2 counters, and n is equal to 3 because we are finding a cube root. So I hope this is helpful for you guys taking complex roots. Thanks for watching.